Welcome back to the channel with solutions of practice problems for actuarial exams. This is a problem for exam FM on financial mathematics for August 4th, 2017. You can find information about me at smarturl.it/Jedi, and you can find information about the actuarial program at Illinois State University that I direct at smarturl.it/actuary. My advice on how to pass actuarial exams is at smarturl.it/pass. If you would like to make a tax-deductible donation to the actuarial program at Illinois State University, you can go to smarturl.it/help-ISU-actuary. Here's the problem. An investor purchases a 10-year callable bond with face amount of $1,000 for price P. The bond has an annual nominal coupon rate of 10% paid semi-annually. That means that really it's a 5% coupon per half a year. 5% of 1,000 is 50, so it pays 50 every half a year at the end of the period. The bond may be called at par by the issuer on every other coupon payment date, every other, which means every second one, so at the end of each year it can be called, beginning with a second coupon payment date, so at the end of the first year, starting at that date. The investor earns at least an annual nominal yield of 12% compounded semi-annually regardless of when the bond is redeemed. Calculate the largest possible value of P. Now 12% compounded semi-annually is 6% per half a year. That's important to note here. The higher the price paid for a bond, the lower the yield received on it. It's a general principle. You should be aware of it. It's not very complicated. Remember that. This is why the question asks for the largest possible value of P. The price P works this way, that if the price paid for the bond is P, yield on the bond, if the bond is called at the worst possible time for the investor, is still 12%. Annual, nominal, compounded semi-annually, so really 0.5% per half a year. If the price is higher, yield falls below that 12%. If the price is lower, yield may be even higher. Also note that the investor earns 6% per half a year effective, while the bond coupon is 5% per half a year. Thus, this bond is purchased at a discount. The market price is below the par value, and the bond can be called at par at each year's end. Trading at discount, the bond gradually increases in price until it reaches par value at maturity. This is not clearly indicated in the problem, but you are expected to assume that the redemption value is equal to the par value, and the bond can also be called on the same date at par value, at maturity at the end. So if the bond is called at any time prior to maturity, the issuer would be paying $1,000 for a bond worth less than $1,000. Not a good idea. You can also think about this in terms of interest rates. If the bond is called prior to maturity, the issuer will be effectively paying off a loan charging 5% interest per half a year, while the market rate on the loan is the current yield, so 6% per half a year. So why pay off a 5% loan when you would have to borrow new money at 6%? It does not make sense. So the issuer will not call the loan and will wait till maturity to pay it off. This means that the price is determined based on the idea that the payment of the principal will come in 20 half-a-year periods, and there will be 20 half-a-year periods when the payments of coupons of 50 will be made. So we're basically pricing this bond as a bond with a coupon of 50 over 20 periods at 6% and maturity value of 1,000. And this is basically the Frank formula. FR, the amount of the coupon, A angle N, plus K, the present value of the redemption value. I call it again Frank formula because that's what it spells out. And we calculate this to be 885.30, which is answer A. Please remember this is copyrighted material, and also problems from Society of Actuaries are theirs, reproduced with permission, but you have my solution for this one. Good luck in your studies and good luck on the test.